Welcome back to freehighschooleducation.com. Today we are going to start chapter 3 in Algebra 1, and the title of the chapter is Solving Equations by Adding or Subtracting. Here you have a picture of scales, and the scales have two equal quantities. And if you remove a certain amount from one side and you remove the same amount from the other side, then the two amounts will stay equal. So let's see how this happens in algebra. Five is equal to 5. We have 2 and 2, and these two quantities are equal, and I remove or add these two quantities to the other two quantities. Then I will have 7 is equal to 7. If I minus, I will have 5 is equal to 5, and I'm minusing, and I will have 3 equals to 3. Notice that the quantities I started with at the beginning are different than the quantities I subtracted or added, and the final product is also different. However, all these quantities share the same common property, that they are both equal on both sides. Now, if we apply this to algebra, this is the basics of solving equations in algebra. For those who have taken geometry and started with us the geometry course, you already know the axiom. If equals are added to equal, the sums are equal, or if equals are subtracted from equals, the differences are equal. This is applied here in numbers. So, also here they give you the rules in the blue rectangles. Let's take an example. X minus 12 is equal to 9. So now if I want to get rid of this 12, and my technique here to solve this equation is to isolate x. I want x on one side and equal whatever number here on the other side. So my technique to isolate x is to get rid first of the 12 on this side. And I do this by adding 12 to both sides. And then I will have x, this will be a 0, and we remember from the property of 0, you add it to any number, it does not change the number. And we add these two numbers and we get 21. So my x is equal to 21. If this was a plus up in the original equation, then I simply change. Here we need to change this to make it, for example, 14. And if this was a plus, then I will change this to minus minus, and then I will have x is equal to 2. Again, these two give me a 0, and I minus 14, minus 12, and that gives me a 2. This is a very simple chapter. However, the applications are very broad in solving word problems. So we will do some of the examples from the classroom exercises on page 92. We do exercise number 1. X minus 12 equals to minus 32. Again, to get rid of this 12, I add 12 to both sides. And I get x is equal to, and here minus 20. I'm adding a minus to a plus, so I put their difference, and the sign here would be the sign of the bigger number. In this case, I have more minuses than pluses. We take another example. We'll do example 2, number 2. Here, my unknown is on the other side of the equation, which is basically on the other side of the scales. It really doesn't matter. 46 equals to y plus 7. Again, I want to isolate y, so I minus 7 from both sides, and I get rid of the 7 from this side. So I get a 0 and a y here, and on this side plus 39. So y is equal to 39. Another example is number 8. negative on the other side. Y minus 2 over 3 is equal to minus 4. I add 2 over 3 to both sides, and we get y is equal to, this is a negative and this is a positive. So I borrow 1 from here, so I will have minus 3. And the one that I borrowed will be 3 over 3. So I take away 2 and I will have 1/3. So y will be equal to minus 1/3. Now let's see what really happened here so we can do these exercises in a faster way. Y minus 12 equals to 14, for example. All I did in this case is take the, add the 12 here and add 12 here. So, in effect, I took the 12 to the other side and changed the sign. So to quickly do these exercises, you simply move the constant number from one side to the other and change its sign. You can do this also with the unknown. If I decide to move y to the other side, then I will have here a 0 because there is no more y, and that will be 26 minus y. This will be the same as this equation. I can take back the 26 here, and my 26 will be minus 26 equals to minus y. I multiply everything by minus 1, and I will have here 26 equals to y. This step we will do later on. The point is, I can move any number from one side to the other, provided I change its sign. And the reason you can see here, because equals added to equals, the sums are equal, or if equals are subtracted from equals, the differences are equal. Our last example will be a word problem, a simple one. The $44 selling price of a sweater is the cost increased by 18. So my cost is unknown, so that will be X. I increase it by 18, and I get the selling price, which is 44. Again, my X is equal to 44, and I move the 18 to the other side, and that's minus 18, and I do the minusing, and that will give me the value of X. Another quick example is number 24. 8 less than a number is 56. So I have a number, and I take away from it 8. So 8 less than the number is 56. Again, I need to isolate my x, so I get 1x is equal to whatever number. I take this to the other side and change the sign. Before we do this, we must understand why we can take the number to the other side and change the sign. Again, because we are adding to both sides to make this quantity 0, and then we have to add the same quantity to the other side. So the basic principle behind moving it to the other side and changing the sign is because of the rule adding and subtracting of equals. With this, we come to the end of this class, and we hope to see you again.